Welcome everyone to our final event, actually, which is the results of the hackathon, the AgentCraft Hackathon that I've conducted in conjunction with the LangChain. And it was an amazing event, as I found it. Amazing participation of people from countries around the world. Also teams of people that didn't know each other beforehand, and then they met up and did great work together. And so finally, there were exactly 40 different teams and projects which were submitted both as a PR to the GenAI Agents repository that I run, and also each team submitted a YouTube pitch talking about what they did. So you can find everything on the GitHub and with links to the YouTube. So far, I've approved 25 PRs. Not all submissions were qualified to appear on the repo because we need the high standard. So currently 25 were already approved, and several more have some remarks, and they're going to change it, and I'm going to approve them soon on the coming days. And so all 25 are definitely amazing works. So I'm very proud of all the participants, and I believe that everyone who is going to see the project that is submitted is going to think similar. And it was very hard to decide which are going to be the winners. I'm gonna tell you this. It was very, very hard, and the way that we did it was to score every single project according to the criteria that we defined before. And we did an average between the scores that the mentors gave the works, and just pick the top submissions by this. And saying this, the third and the fourth places were very, very close to one another. So we decided to take both of them as the third place. And so actually, we're going to show you 4 projects today in this event. And well, I guess that's it. Just saying that the second place and the first place, the projects are kind of similar, I would say. There is some kind of overlap, but there is a difference, and I see them as complement projects. So yeah, so let's start. I have here the participants, the 4 winning teams, 1 representative from each team, from those who have more than 1 participant. And so we're going to start from the third place for today. And I'm just going to say that the prize for each of the third places is going to be $5,000 in Azure credits and $3,075 in Langsmith credits from LangChain, and additional $250 in cash. So the third place who is going to present his work for us today is going to be Adrian, who's done an amazing work called Kiron. Hope I pronounce it well. So yeah, go ahead, Adrian.
Yeah, thank you very much. So I will start to present my screen. Okay. Yeah, but I can't share my screen.
So if you can, what we're going to do, I'm going to make you a host for the time that you're presenting, and when you finish, please make me host again.
Okay,
Right.
thanks. Okay, thank you very much, Kiron. Kiron is a Feynman-enhanced learning agent using LangGraph. And what is Kiron? Kiron is an agent designed to facilitate one-on-one learning between a student and a teacher. But this is not just any teacher. The prompts incorporate Professor Feynman's teaching techniques, such as explaining concept in one's own words and using analogies. The agent can be divided into two main components: the collecting checkpoints and context part, and the learning part. In this presentation, I will walk through the process occurring at each node step by step. So the first node is the initial state, which encompasses learning objectives and context definition. In this node, we define the subject matter and the learning objectives, which can be just a single general goal. Additionally, if we are studying for something specific like physics tests, we can include our own notes or different kind of context. In the second node, we create checkpoints based on the information from the initial state. During this checkpoint generation, the LLM creates a detailed checkpoint description and assessment criteria and defines specific verification methods for each checkpoint. This node is the interruption part. It's basically a human in the loop where users can actively participate in the whole learning process. So in this node, during this phase, learners can review and refine the generated checkpoints, maintain flexibility to add, remove, or modify them. If the next in the next node, if the student has provided context, the semantic chunker divides it into meaningful segments, which are then converted into embeddings by the OpenAI embeddings model. And finally, these process chunks with embeddings are stored in the LangGraph's in-memory store. If there is no initial context provided, the system creates targeted search queries to gather necessary information from the web search in the next node. Going back to the chunked context, so we have a context validation process. The system evaluates each checkpoint's criteria against the available context that user provide in the initial state. It retrieves the three most relevant context chunks from our storage and uses LLM to verify whether these chunks fulfill the established criteria. Finally, we have search web. If there is some gaps found in the context validation, the web search in this step supplements these gaps, or when you didn't provide the initial context, it executes generated search queries and updates the context store with new embeddings. Okay, we jump into the learning part. So the first step involves question generation using the Feynman technique. The system generates Feynman-style questions based on the established checkpoints. Next, we have another human in the loop. In this one, the user provides their answer to the question. It's just a simple helper node with interrupt before. Then the performance assessment phase evaluates the user's responses against the checkpoints and context. If the score falls below 70%, the system activates teacher mode to provide additional support. For scores above 70%, the student advances to the next checkpoint if this checkpoint exists. The teaching step activates when additional support is needed. So during this phase, the system provides simplified explanations in Feynman's way, emphasizes key concepts, and uses analogies to make material more accessible. Then state is updated with the checkpoint counter, keeping track of the number of questions already answered. And if all checkpoints are addressed, it ends. So I want to add some words about the limitation of this agent. The agent has several limitations that I could address in the future iterations, and I would like to do it in the future. Beyond web searching, it would be valuable to add alternative information sources such as Wikipedia, Archive, or custom vector databases. And what's more, I could split the agent into two separate components. That's like I did in the presentation. This way, a teacher could handle the checkpoints and context section, and then provide students with access to just the learning part. So one teacher can provide, for example, this learning part to the bunch of students. And then the system currently lacks a node retry with a breakpoint, which would allow users to decide whether they want to attempt answering a question again or not. And that's all. Thank you very much. If you have any questions about the project, feel free to ping me on Discord. And I'm also planning to develop a web application featuring this agent. So I will keep you updated about the progress on Discord. Thank you.
Thank you, Adrian, for this. And so currently no questions on the live chat, so we can continue to the next lecture, which is going to be held by Marcus, who is also sharing the third place, and his work is Graph Inspector.
Yeah, perfect. Let me share my screen.
Can you share now? Yeah.
Yeah, I think I can.
Great.
Are you able to see my screen?
Yeah.
Perfect. So yeah, first of all, I'm so glad to be here. I'm Marco Reyes, and let me introduce myself. I'm a performance tester and a Python developer. Well, as a Python developer and a tester, I have been working in the software engineer world, and it gives me the ability to see the whole process of the development software. It's the happy part. It starts at coding. We did some block of code or an application. Then we test it. And finally, the last stage is give this product to the people, to the production, the real world, where actual user will interact with the application. This is the happy path, but in reality, things can go wrong. And when things went wrong, it's chaos time because the company will have some fine. Potentially, you will lose some user, and also there is a possibility to have some data leaks and things like that. Also, it start a emergency call from the CEO of the company to the software engineer team, and it start what I call the blame game. Devs start blame on tester because devs say that all the testers need to increase the coverage percentage of the application. But tester blame back to devs because the tester says that devs need to create or develop most robust application. So the question here is, we can avoid this kind of situation. We can get, for example, 100% of coverage for the test cases. And unfortunately, the answer is no, it is impossible. Because in real world, if we would like to test the whole software, we need a huge amount of resources, a huge amount of time and money. And to make things worse, when we are working with with LLMs, the things get worse because when I write a piece of code, I know exactly what each line of code does. I know for one input, I will get a specific output. But for LLMs, this doesn't work like this because I can have an input, and with that input, I can have multiple outputs. Somehow, LangGraph help us to get more control over this kind of systems, but it is not enough because it still have the properties of a LLM system. I can have an input, the same input, and I will probably get different outputs. So is there nothing left to do? We need to accept that every system has problem and we need to live with that. Well, actually, no. We can do something. For example, for LangGraph system, we can try to increase the percentage of coverage as much as we can. To do so, we can use LangGraph itself to test another LangGraph system, a target LangGraph system. This will be the LangGraph inspector. This inspector will be able to see inside the target graph and see what is going on inside it. It can see the inputs and the outputs of the system. It can see which node it has and how they are connected to each other. This is the main idea behind my project. So the inspector, we need to work a target graph before it is compiled. Also a graph description, what it does and what it is for. And finally, a valid input, a template or input that we can pass to the target graph using the invoke method, and we can run several tests. At the end, what the inspector gave us is the insight or the results of all of the tests that have been run. But let's see in action. Let's see this in the code. I have here the Google Colab code with a very simple example. This is a target. This will be the target graph. It's a very simple graph. It only have two nodes, an assistant that will be tasked with performing arithmetic on the input on the user input. Then there is a node for tools. In this case, the tools will be three functions: a multiply, an addition, and a division function. And that's it. The system will get the user input, it will perform some arithmetic operation, and then give the results back to the user. These will be the three input that the system will need to operate. The description that says what the system, the targeted system does, the valid input, and the graph before it is compiled. Because if we can see, it haven't been compiled. Then we can run this graph, and finally the result will look like this. There have been run several tests. Each one has its assertion if it passed or didn't pass the test, how it performs, and if we need or want to know more details about how the system performs, we can look inside the details. For example, we can find the tester who did the test. In this case, it was a functional tester. The test description, also the assertion criteria, and we can see the actual output that the system performed. Let me check for a more complicated. For example, this one, the system tried to make a string input, and if we can see here, here it is the input that the system generated based on these test cases. Well, let's go dive deeper and see how the system did that. Actually, it's very simple. It's not a very complicated system, but it's a very good one, I think. Well, it starts with gathering information, as much information as we can gather from the graph node. We then generate some tester. With those tester, each one will generate some test case for each node. Then we can create an input, a variation of the initial input that tests what the test cases say. Finally, we run all those test cases with the new input and we analyze the results. We can see how the system achieved this. Let me just, here we go. For example, when we gather information for the assistant, we have the type, the runnable, so we also could be able to run this node individually in the future. If the tool has nodes, it will be there, the name and also a description. The description is made taking an actual input and an actual output of the system, because we run once the system when using the valid input that the user provided at the beginning. Then we can create the tester. Each tester has an ID, a role. For example, for this round, we have a functional tester, an anti-injection and jailbreak engineer, and a vulnerability bounty hunter. Here we have also the description that we will be able to pass to the as assistant messages for future operation. Then we generate the test cases. Each tester, we generate a couple of them. For example, for this one, this test case has a name, a string large number division test. It also provides a description and an acceptance criteria to check if this will pass the test or not. Also, we have an important part that is the input. The tester is able to create a new input, but this new input is a string format. You can see it is a string. So we need first to convert this string into an actual Python object that is this one, and then we check if this new object have the same type of the input, the valid input that the user provides at the beginning. If there are the same type, the graph will be invoked. Finally, yeah, we run the test and we can get the information, or we can get the graph history state using the test ID, the tester ID, and the test case ID. And yeah, that's it, how the system performs the operation. It will compare the output with the assertion criteria. Finally, for future improvement, I think it would be very interesting to let the tester the freedom to collaborate to each other. So it will brings the possibility to have more complex scenarios. Also, this tester will have access to the internet, so they will reach, for example, what are the latest criminal methods to break down LLM systems. And one of the most important improvement is human in the loop. I designed the system to include it. So I think it will be very crucial. For example, creating the tester, the human could say if it is needed, add a new tester, or maybe remove one of them, and the same thing will happen to the test cases. The human could say to edit, modify, delete, or add a new test cases. So this is my project. Thank you so much for your time, and thank you, Nir, for this opportunity. If you have any question, please let me know in the Discord server, or you can contact me in LinkedIn.
That is great. What a nice presentation. Thanks, Marcus, for this.
Thank you so much,
And,
Nir.
great presentation, also great work. I also really like your YouTube video.
Yeah, it
Yes,
was a very good one.
I
Thank you,
recommend
Nir.
everyone to watch it. Okay, great. So now let's go to our second place, who is going to be Bradley, whose work is systematic reviews of scientific articles, and mentioning that the prize for the second place is going to be $5,000 in Azure credits, $1,000 in Langsmith credits from LangChain, and additional $1,000 in cash.
Nice.
And go ahead, Bradley.
Sure thing. So I don't have a PowerPoint presentation, but I do have a Jupyter notebook that I can walk through here. So
Sure.
let me pull that up. So this is the Jupyter notebook, or the Google Colab notebook that I wrote for the hackathon. This is the systematic review of scientific articles, and my goal for this project was to just take a topic that I was interested in and have someone give me like the too long don't read of all those academic articles. But then I started to think about the idea a little bit more, and was thinking maybe I could have this this agent, or this workflow, analyze some papers and also give back a systematic review of those scientific articles. So more than just a too long don't read, but actually sort of compare and contrast the approaches of some of the techniques done by different papers in similar fields. So I sort of gave a rudimentary shot at doing this, and this is what came out of the hackathon. So as you can see here, it looks a little beefy. This graph looks a little beefy, but it's not too terrible. I'll just walk through it really quick here. So what do we have here? At the beginning, you want to like put in a topic. So for me, I put in just like what's going on, the latest diffusion models for music generation. So I type in that, and what we're going to do is we're just going to process some input. We're going to pass this just getting sort of the state graph set up here in LangGraph. And then we pass it to this planner node. And what I've seen throughout the with other agents, like recently I saw a podcast one that was on Nir's GitHub. They had a very similar approach where they had a sort of a planner node and a researcher node. So I sort of use that paradigm as well, where we are given an input and you plan what you want to do for the systematic review. So how do you want to set up the systematic review? And then once we get to the planner, we go to the researcher. So the planner is going to send the prompt and information about the plan to the researcher, and the researcher is going to create a bunch of queries. So in this, for this particular node, I told the prompt to give me five queries and send these queries to a tool, which I've created, is called an academic search tool, and I specifically query the semantic search API. So 5 queries to the semantic search API, and I got back 20 results each from each of those. I think that's what the agent is defaulting to. And when we get those papers back, you don't get the full context. So you don't get the full text from semantic search. You get the PDF, you get the apps, or you get the PDF like link, like the open access link that you can download. And then you also get the text, or sorry, the abstract, plus any other information associated, like metadata associated with the article. So then after you have these, at least in this case, I had 60 or 80 articles, I believe, at least in this demo. And so the article now decides which articles it wants to download and analyze. So based off of the research plan and the prompt, we decide which articles we want to download. And for the sake of brevity, because I didn't want to use all my OpenAI credits, I set the prompt to about to three articles to download. So this is what that article decisions node is doing. You can actually change this if you want to. I've tested it out with up to like 8 to 10 articles. The sort of the drawback is it takes a little bit longer to run because you're going to be analyzing 8 to 10 articles at a time. So what we do next is you pick these 3 articles and then you download those articles. So what I've done here in this notebook, in this prompt, is you download them and you pass them into this this data folder, and this will also be in the demo notebook as well. So you'll pass your articles to a data directory, and then we analyze each paper individually. So there's a prompt here that analyzes each paper individually, and right now I'm doing it sequentially. I tried to do it with parallelization, but there seem to be, I think there's some limitations with OpenAI's API, so I sort of just kept it sequential. So right now, just for the demo, just cap it at 3, but I'm trying to make it so that there are parallel processes for analyzing each paper. So after I've analyzed each paper, what I wanted to do was have the paper write a systematic review. So I took all those analyses and passed each one of them to each node here. And each node is responsible for writing a specific section of the systematic review. So we have an abstract, an introduction, a method section, a results section, conclusions, and then some references. So the references that were actually for the papers themselves. And then I have this aggregation node, so it aggregates all those papers together. So this isn't using any LLM, it's simply just putting all of these resultant texts together. And then when I go here, I ask the model, the LLM, to critique these sort of conglomerated pieces together. And we give the agent 3 choices. So you can either revise the paper and sort of come back with any like suggestions, fill out any of the suggestions that the critiquer was doing, and then it gives it back to the critiquer. And you can sort of do that cycle over and over again. You could also, if the critiquer didn't think there were enough papers or enough information to adequately address the planner or the original prompt, we can go back and research more articles. So if that was true, we could go ahead and do that as well. And then finally, you could also just submit your final draft here. So those are the 3 choices that were made. I think it'd be useful to show some of the flow here. Let me show the graph, state graph. So this is the state graph, or how the graph was generated here. So we have all of our nodes up at the top. We have our nodes for writing papers. We have our nodes for researching, and then we have our nodes for refining. Where the agent is really making those choices is in this conditional edge. So at the critique paper node, it's going to decide whether it wants to output a final draft, whether it wants to revise paper or research those articles again. And let's see. So those are the graph components. I think the most important things in this agent that you'll notice are these prompts. These can certainly be refined, but I think one of the ones that I think is most important is this analyze paper prompt. So I'm analyzing each section of the paper. I'm telling the LLM to analyze both the abstract, introduction, methods, and results sections of each paper, and giving back a response that looks like this. And then these would be sent to all of these. The results of this prompt would be sent to these. And then the last one is this critique draft prompt. I think this was important to do as well. So you can, it gives the three choices where you can make a revision, you can end the draft, or you can, I can see that I've commented this out, so might not have actually gone to research the articles, but you can actually paste that back in and do that as well. I've tested it and it works. So you can use that. And I think, how am I on time? Am I okay on time? Good.
Yeah, you're okay. I just saw a question from the crowd, which I believe you answered by the time that I saw this.
Okay.
Just I'll repeat it. Anyways, so he's asking, how is the critique organized or structured?
Yeah, right now it's very basic. So I'm just saying you are an academic researcher deciding whether or not a systematic review should be published, generate a critique and recommendations for the author's submission, or generate a query to get more papers. If you think just a revision needs to be made, provide detailed recommendations. If you think the paper is good as is, just end with the draft unchanged. And it might be helpful to actually go through and show the what that critique function looks like. So we have our aggregator, it's just aggregating. And then I just take in this draft, and then I take in that review outline that was from the planner. And then I pass in that prompt as a system message plus the draft and the review plan. And then I just get a response back. So that response could be those three things based off of what I've given the LLM agent through the graph. I have also capped. I also did like a cap on the number of revisions, so it just doesn't go in an infinite loop. So that's also in the state as well. So I set the revision number. I think the max revisions in the demo is 2. You can certainly increase that, but each time a critique is done, the revision number goes up as well.
I have a question that if you had to improve this work, which part would you improve?
For me, I think the planner is actually not that great right now. There's a lot to improve. I created another repo just to sort of refine this, but I think right now, like this planner and researcher, like before I've even done anything, I'm already planning, like I get the basic query and I'm already planning something without having seen the results of the paper yet, results of any papers. So what I would probably want to do is after I've done research and found these articles, maybe in this decision prompt, is to revise this plan. So maybe go back up and revise the plan. I haven't thought about how I'm going to build that, but I would imagine like I need to do something that sort of iteratively goes back and updates the research plan with accordance with the papers that were found from the search. I think that would help the probably help the analysis as well. I think another couple things I would do is probably the sections. I think right now in this analyze paper prompt, I think it's a little too simplistic. Right now, I'm just telling the prompt, just take this paper and analyze it and just break it down into key components here. But I think I would want sort of again, I haven't thought about this fully yet, but I would want something that probably breaks down these papers a little bit more so that the actual draft of the final draft that comes in is maybe a little bit more meaningful when it comes to how it's dissecting each of the papers in the systematic review. So those are sort of the things that I'm thinking about right now.
And if you need a very good literature review, I think that it's worth waiting to see what our winners made.
Oh, that's great. That's great. Awesome.
Yeah. So thank you. It was amazing presentation and amazing participation as well. And so going to our first place team, consisting of Ahmed and Vincenzo. I hope I pronounce both of your names correct.
Yes, that's exactly correct.
Yeah. And so the first place prizes is going to be split between the two of you, but for the first team is $5,000 in Azure credits, $1,500 in Langsmith credits, and $1,500 in cash. And the work is called Nexus AI, scientific paper AI agent. Go ahead, one of you who's going to present it, or two of you.
Sure. So I'm gonna take the lead and present. I'm gonna share my screen just now. Just someone please confirms that you can see my screen.
Yeah. Yeah.
That's good. That's good. So welcome everyone. Luckily we're the first place in this hackathon. Our project is called Nexus AI. It's a scientific paper analysis agent. It's hosted by DiamantAI and in conjunction with LangChain. As a researcher, I almost always every day face a problem, which is a time-consuming task of literature review. Typically, as a researcher or as researchers, we spend about 30 to 50% of R&D processes invested into literature review. That hinders the process of innovation in research. You know, there are a lot of things we can speak about here: inefficient of search processes, resource intensive literature review, and many more. Use cases. So we initially built our agent based on real life use cases. It isn't out of personal interest. So what we actually saw is that primary applications that could be used based on our AI agents are literature review, paper analysis, real-time updates on what papers are out there, and we could do also cross-paper analysis. Now, target users that could actually benefit from this AI agent are research institutions, industrial R&D teams, students, and academic researchers. Let's dive into the LangGraph implementation. So our research assistant is built on a state-driven workflow engine powered by LangGraph, implementing an intelligent 5-node system that mirrors the scientific research process. At its core is the decision-making node that acts as the entry point, analyzing queries and determining the research path. The planning node formulates structured research strategies with the tool of using core API query. So actually in the system prompt that we used for planning agent, we had a predefined query, which is the specific core API query language. Core API is a open source research database. Any of you guys could get access to a freehold of API keys. So this API supports sophisticated queries with Boolean operators, field lookups, and range filters to retrieve specific papers. What makes our system unique is actually it's a quality-focused architecture, or we could say that it's more reliable and robust than most of the tools that I've seen or we've seen out there. The judge node evaluates response against strict criteria, initiating improvement cycles when needed. The entire workflow is again powered by LangGraph, managing states between different transitions and nodes. We used PDF Plumber for PDF processing, and we also used Pydantic to ensure data validation. Think of this as an intelligent research pipeline. Some of the challenges that we faced during developing this AI agent is that initially, while iterating through the agent, there almost used to be a fixed response pattern. That's why we decided to integrate, let's say, a judge that evaluates the responses based on a predefined criteria. Another thing that we faced is that the agent would pull almost all of the information from the research instead of some specific information. That's when we actually also introduced some smart query routing techniques. Moreover, that to enhance the PDF reliability, we used some robust retry mechanisms, which is basically initiated in between the agent and the tool and the judge. Some example usages. So in PhD academic research, one of the main things that researchers do is paper search. So here, as an example, you could see we input the agent by a query which says, okay, find 8 papers on quantum machine learning. And then it processes that through the AI research agent and gives out a structured output of papers, the list of papers containing different metadata. Let's say author, publication date, small abstract, and also the URL to access the PDF paper. The second example use case is the paper summary. Actually, we input a query with also the source link of the document, and it actually analyzes different parts of the paper. So if we say, download and summarize this paper, and we give it a paper link, it goes through the agent, and then we have a structured summary of what is it about, what are the formulations, what are the studies mentioned, and what are the challenges in future direction, in addition to the potential impacts. It also, could give us some information about, is it a systematic review? Is it a metadata review? Is it just, like a certain review, or what exactly paper is about? So actually, to also evaluate our agent, because we didn't want to do something and just say, oh, hey, we're the leading there, or it's the best thing out there. We decided to actually evaluate our agent on some benchmarks out there. 2 of the most famous benchmarks out there that you could use nowadays are Microsoft Copilot and Perplexity AI. As we can see, our agent actually takes more time in processing the query, but it gives much more better outputs as metadata quality. Metadata quality is basically, it pulls out the information from the paper, which are the authors, when it was published, abstract, and moreover that. It also is much better in an academic rigor standpoint. If you do a random search in any of the chatbots out there today, you say just, hey, could you give me 8 papers on computer vision and open set recognition? It would give you a small description of, this is the paper, it was published at this time, these are the authors, without any more information. You would be required to go and then later on search for the information by yourself. By comparing that when using Microsoft Copilot and Perplexity AI, we see that Microsoft Copilot actually doesn't cite the link to the paper, but Perplexity AI does. We also observed that our agent gives much more structured output than other solutions out there. So it's a matter of trade-off between processing time analysis and depth of the answers or analysis that you get. Here is a more deep dive into different metrics of different solutions. I won't emphasize a lot on each individual one. You could refer to our open source Jupyter notebook under GenAI DiamantAI repository. We can see that actually, just a quick look, we can see that our agent actually performs a better academic validation on the outputs because of the judge node rather than other solutions out there. That's the main, actually, that's one of the most important things of our work, is that it's a kind of a reliable system. We're not just getting an output and okay, take the results and here you go. So it's a matter of how does actually the judge evaluates the response based on a predefined strict criteria. Agent analysis. Another thing that I actually wanted to measure is that how does the agent affect the R&D processes? So I tried to do literature review by manually searching for papers and by going through our agent. And then I realized that most of my time in an hour, actually, doing a traditional method, it was like about 40% of the time I was just spending it on literature review. Meanwhile, while using the AI agent, I could reduce this time and actually put it into other specific areas of R&D as experimental design, data collection, analysis, and writing and publications. Some of the future directions and limitations that we envision, we actually envision that it would be an open source repository on GitHub, so anyone could use this R&D tool later on. One of the things that we face is the technical limitations and functional limitations. So currently there is a limit for API runs because of the OpenAI API keys. It takes a lot of time to process large PDFs. There are some research that are published in CVPR that has about 30 to 40 pages. That takes a bit of time to actually analyze. And unfortunately, since it's an open source, we can't really access archive papers or other databases. The only thing that we found was core API. Some of the functional limitations of our agent is that we don't have yet image analysis. It's a limited context window. Our agent can't actually, comprehend math derivations, and it supports English language only. So what we could do to address these problems is implement multiple AI integration, parallel processing, and some caching systems. Moreover, that we could also include figure and table extractions, cross-referencing, interactive feedback, progress rating, and the option to export results that you got. Thank you everyone for listening. It's done by me and my partner, venture partner, Vincenzo. Thank you so much for listening. Thank you.
Thank you very much, Vincenzo. You want also to say something?
Yeah, no, I think Ahmed covered most of it. Maybe just a few things that I think are interesting to see. Maybe I can just very quickly share my screen because as Ahmed mentioned, there were a few technical limitations that we expanded. But yeah, just to give a quick idea, let me see. Yeah, basically we had to add the core API basically language, for example, to the prompt, and we noticed that already just doing some in-context learning for the agent helped a lot, or also adding feedback or adding some additional elements in the PDF download. That was really helpful, and I think that's what really drove up the accuracy for us. So just to give a quick overview.
Well, I think it's a well-deserved first place for this hackathon, who beat Perplexity AI and Microsoft Copilot. And I'm waiting to hear from other people who are going to check your system and see how it works for them for their research, and maybe combine it with Bradley's work and writing the paper with this. And well, so this is actually it. I'm very proud of any one of you, and also all the other participants of the hackathon. As I said before, all the works that were good enough in the quality needed for the repository were accepted, and I'm going in the next coming weeks write about these agents. So every one of you is also going to get additional social acknowledgement. I hope a lot of it. And yeah, I guess that's it until the next time. So thank you for all of you for being here today, and goodbye.
Thank you so much, Nir.
Thank you.